Okay, thank you everyone for joining us today at online live event to learn. I'm Jessie, the host from AI Camp. Before we get started, just want to do a quick introduction on AI Camp. We are a global online platform for developers, engineers, and data scientists to learn practice AI technologies. With mission of make AI available to all developers, AI Camp has grown to over 17,000 tech engineers in the group, have hosted over 300 local tech meetup, workshop, bootcamp, large tech conferences, and live stream most of tech talk globally. We have local study groups in the most major cities in the US, a few cities in the Europe, India, China, and Australia. You can take a look at the website to see our upcoming tech talks, workshops, and crash courses that we offer. And here are courses we offer for upcoming weeks. From January 8th to January 17th, every Tuesday and Thursday at the evening, we have the topic is build machine learning pipeline. And from January 29th to February 7th, every Tuesday and Thursday morning, we have the topic automate ML in practice. And January 30th to February 1st, in the morning, we have the tutorial to build share AI service. And we also offer the webinar on January 30th, Wednesday, at 6 p.m. with the topics understanding machine learning. And most importantly, we have our AI NextCon Seattle conference from January 23rd to 26th. It will be 4 days, 50 plus tech lead speakers, 60 plus tech talks, 6 workshop code lab. You will meet a lot of great people, and it's time to learn and build up your connections. And we are very excited to have Conan today. In today's talk, Conan will unveil the challenge with data and to build data-driven feedback loop to address these challenges. He will also share vision to data centers. And Conan is the director of technical PM of Salesforce Big Data team. His PhD area in parallel data on GPUs. He has worked on SQL servers, Office big data systems at Microsoft, and big data product at FutureWay. Without further ado, let's welcome Conan.
Thank you, Mika. Can you guys see my screen?
Not yet.
Do I need to share? Oh.
I think you just do, yeah. Now we can see the screen, yeah.
Okay. Hello, everyone. I'm Conan. Thank you, Mika, for introducing me. Just a little bit more of myself. I worked for Microsoft for 8 years on big data and databases. And then I was working on architectures of public cloud big data products. I'm currently with the Salesforce big data team. And I live in Seattle. Seattle is a beautiful area. The climate is cloudy, and technology-wise, it's also cloudy with many very good cloud companies. And behind every cloud service, there's a data center or more data centers that supports it. Today, I'm going to share with you Salesforce data centers. But perhaps more important or more interesting to you guys is to use data center as an example to demonstrate how to build a data-driven feedback loop. I think there's a comment from the users. Let's see. Not savvy on Zoom. Maybe Mika, you can help if there's any questions or comments online, or I can address them after I finish the slides.
Yes, of course. We will have a Q&A section later, so we can answer those questions later.
Okay.
Yeah.
So before I start, here's a forward-looking statement. You should be making your own purchasing decisions based on what's available currently. Here's my outline. First, I'll talk about the background of the company and the project. And then I'll share the technical challenges of operating our data centers, or in general, operating data centers. And then I'll describe our approach and solution of using big data and AI to solve those challenges. And last, I'll share some vision and the lessons learned. Salesforce is world's #1 customer success platform, and thanks to all of you guys, the trailblazers. What we do is we help all the companies to connect to their customers across all those customer touch points, such as sales, marketing, service, commerce, etc. We have been doing well. Our revenue hit 10 billion last year. And thanks for the rankings, we are also ranked as #1 best companies to work for, as well as most innovative company. Excuse me. And here's Salesforce Cloud architecture. On the top layer, we have various applications such as Service Cloud, Sales Cloud, Marketing Cloud, etc. And companies can also develop their own apps. And in the middle 3 layers are the platforms, including dev platform, AI platform, and data platform that support these applications. And the bottom layer is the infrastructure that provide all those cloud computing resources for the platforms as well as the apps. And sit within this infrastructure layer are our data centers, which is my topic today. So here is Salesforce data centers. Ta-da! We have 9 data centers as of now, and they're still growing. I have a link here where is my Salesforce instance located. If you search online, you will be able to see our article listing all these data centers. So like many other public cloud providers that have their own data centers, we operate our own data centers as well, and we share a lot of common problems and challenges with them. But unlike them, a lot of services we provide are infrastructure instead of external facing end user products. So if I ask you, what are the core values of data center operations? In my opinion, there are 3 challenges or 3 key values. The first is trust. And that means when my services are running on your data center, I expect my services to run reliably, securely, without any problem. And the second one is agility. That means when I need some new cloud computing resource, I want it rapidly. The third is cost. To me, I want to pay less. And to the data center operations, it means to lower their cost on both hardware and operations. However, it is actually not easy or very challenging to meet all these 3 key values in the same time. Let me just give you a few examples of operating our data centers. The first is provisioning. Provisioning is a very complicated workflow. It involves multiple subsystems, from hardware to network to security to OS to software. So with such a complicated workflow that involves interdependencies between so many systems, provisioning can sometimes slow down. And when it slows down, it can harm R&D agility and also brings up our asset cost. The second kind of scenario is repair. When a machine goes offline, it can be anything. Could it be hardware failure? Could it be OS issues? Could it be software? You name it. We have automation logs, but sometimes automation logs do not directly tell us the root cause. And at times, we may even need manual troubleshooting. And with such a big data center ours, manual troubleshooting can be very costly, and also it hurts their operational agility. And then the other example is power. Of course, we all expect power to be up in the data centers. However, there were incidents, and when the power goes off for whatever reasons, our customers, their business are impacted. and it harms their trust in us. So you can see trust, agility, and cost, they form like an iron triangle, and it is very challenging to meet all of them simultaneously. So when we look at these challenges and we reflected what we have, we identified several areas of interest in common, and there are 4 of them. First is data coverage and quality. For example, collect hardware signals, power signals, and all signals from all servers or all hardware. Also, when we have new acquisitions, how can we access the data sources from the infrastructure of the new acquisitions? The second area is data correlation. We have so many different systems. Data can be inconsistent between each other. Sometimes data disagree. And when data do agree with each other, there could be correlated events. For example, is there a correlation between this hardware failure and this software error? Such correlation could be very insightful. And the third category is data timeliness. We have all kinds of signals, but signals delay would mean that our actions are delayed. And even worse, outdated data could trigger wrong actions. And the fourth area is intelligence. Like repair, we have some complicated manual steps that we want to automate, and that needs a smarter way to automate them. So with these 4 areas of interest in mind, we adopted such a roadmap. It consists of 3 phases. This one is working on data coverage and quality. This is like the foundation. Without this, we don't get a lot of value in subsequential phases. So that's the first phase that we were focusing on. After we felt like, we pretty much addressed this data coverage and quality challenge, we started data correlation and data timeliness efforts in parallel. And then we also conducted prototypes and experiments of machine learning projects just to explore the opportunities to optimize things. And phase 3 is where we use data correlation, data timeliness, and the right data coverage to augment and expand our intelligence and scale that out to all our fleet. So as you can see, although data center operations sounds like a hardware-oriented and a traditional IT area, but the approach we are taking is really just a data approach, and it's a data-driven closed loop, and it's also shared with today's internet software industry. Oh, okay. So here's the technical solution that we adopted. Overall, it is a closed loop from data collection to data storage to data analysis to data presentation to our operations team triggering actions, and then all the ways back continue to collect new feedback. And on the collection layer, there are 3 categories of data. Observed data is the factual data that we collect from the hardware. Declared data is defined by human. It tells the target status that we want to arrive at. Inferred data are the logs generated by software and by people, such as tickets and chat history. All this data arrive at a data lake and stream processing, respectively. On data lake, we run the jobs that I just described, including data quality, data cleansing, data correlation, machine learning jobs, and interactive queries, and the others. In streaming processing, we mainly run several anomaly detection tests. And the process data, they go through the presentation layer. There are all kinds of routine presentations, and we also provide chat ops and VR, AR into our data center rooms. And all this presentation are consumed by our operations teams. And each action here in itself has a data feedback loop. So I'm not going to go into technical details here. If you're interested, drop me an email, and I'll be very happy to connect you to our PR and the corresponding teams. So looking forward, I believe data center operations are just like autonomous cars that goes through 3 phases: manual to automated to autonomous. And in operations world, autonomous, we also call it no ops. And I just borrowed these slides from Randy Kern at Dreamforce 2016. Eventually, I believe a human just need to set a goal and handle exception and let the machines to do the rest. So here are the lessons I learned. First, it is a very good experience that I was very happy about the progress we made. We built data-driven closed loops that ensured the trust, agility, and cost of our operations. And using such a trusted infrastructure, we were able to empower our company. And the lessons learned, the first is data coverage and quality is a shared challenge across pretty much every scenario and every service. It's such a challenging yet fundamental issue that we have to tackle. It may not sound as cool or fancy as the other projects like machine learning, but it's very critical to us. The second lesson is, in order to build a data-driven loop, we have to be business-oriented. That means we start from business goals, what we are trying to achieve, and then use that to decide to ask the right list of questions that we want to get answered. And after we get the answer, what kind of actions to follow up to be triggered after that? And use these questions, we can decide the information we need to collect. And then we can define our data source, our data destination, data structure, data processing, and the other things. And only until then can we talk about a so-called big data pipeline or solution. So not the other way around. There are times we were so excited about a specific machine learning technique that we let it fly and generate a bunch of results, but end up with not really helping to answer the real business questions or solving the real business problems. And the other lessons I learned is there are path dependencies around both data capabilities and tooling capabilities. For data capabilities, as I said, data coverage and quality is the foundation without which we cannot succeed. And after that, we have data correlation and data timeliness. And how do they help data intelligence? Data correlation provides more dimensions for our machine learning. And the timeliness basically opens up new scenarios for smarter detection of, say, real-time anomalies. The other dependence on building tooling capabilities is we go from manual to automation to data-driven. If some scenarios are still at manual stage, this is the time we fill up the gap to build some automations. This is not the time we talk about data-driven. And only after we fill the gap can we start building a data-driven feedback loop. And this is all I have today. Thank you, guys.